Hello. We're going to look at another word problem for average rate of change. The projected U.S. Asian population in millions for this same time period is A of t equals 11.14 times 1.023 to the tth power. Use A to estimate the average rate of change in the Asian population from 2000 to 2010. Now, whenever it says the same time period, it says t equals 0 corresponds to 2000. And we also have 0 is less than or equal to t is less than or equal to 50. In other words, from 2000 to 2050. Now, here we want to go ahead and figure out the average rate of change, which means from 2000 to 2010, we have t equaling 0 in 2000 and t equaling 10 in 2010. This is very similar to the question that we just got through doing, so go ahead and pause it here and try to figure out this one from here. Okay, hopefully you've went ahead and paused it, and now we will show you what the solution will be. To do this, we want to figure out what is 0 comma some number and then 10 comma some number. Now whenever you plug in 0, you're going to get 11.14, obviously. Now I say obviously because anything to the 0 power is 1, and all this becomes 1, and we're just left with 11.14. Now if you type this into the calculator, 11.14 times 1.023 to the 10th power, that gives you 13.984. Good deal. And all you want to do now is basically find the slope. So the average rate of change is simply that 13.984 minus the 11.14, then all over 10 minus 0. Fantastic. And when you do that, you're going to wind up with 0.284. Again, I'm just rounding to 3 decimal places. And this, of course, would be million people per year. So the average rate of change is 0.284 million people per year. Now let's talk about what this actually means. This means that every year between 2000 to 2010, the average rate of change, in other words, if you took the total change and then you divided it into each year individually, that every year the Asian population was increasing by 0.284 million people every single year. Now, of course, in thousands, that would be in terms of 284,000. Okay, so we have to be careful with that. But that is what that means. Now, really what this is telling me, well, beyond the average rate of change here, is there's actually a percentage increase every year that we can see from this, because this is just really compounding interest. It's really all it is. It's that idea. So this is really telling me that this is increasing by 2.3% per year. That's what that's telling me. Now the 1.023 is just 102.3% per year. So take the previous year, multiply by 1.203, and that will give you the next year. That's what's happening here. If you remember from the previous one, however, the Hispanic population was increasing at 2.1% from the previous year. Now, the actual physical increase is much smaller for the Asian population than it is for the Hispanic population. But notice that the Asian population actually has, in terms of percentage, is actually increasing more per year. And so when you're talking about increases per year, it really does matter if you're talking about just a flat number or if you're talking about a percentage number. Because if one has a much higher number than the other, then the percentage of one might be higher than the percentage of the other, but it can still be a total amount that's less than the other. But the question becomes, over time, which one will be, if this pattern continues at least, over time, as t gets larger and larger and larger, which one will wind up being larger population? And honestly, it's going to be the Asian population. if this trend continues, because the actual increase per year is larger in percentage format than it was for the Hispanic population. But that's, it'll take a really long time for even parity to happen, which means where the Asian population is the same as the Hispanic population. And I mean a really, really, really long time. But it's just, some of the interesting things about math. Alrighty. Well, I think I'm going to go ahead and end it here, and I will see you in the next video. Have fun.